And yeah, so the topic today is responsibility-driven design in Ruby. So I'm going to be presenting it. My name is Andy Maleh. I'm a senior full-stack engineer. I work at Lexop, which just got acquired by Eltropy. We do debt collection using a Ruby on Rails application. So yeah, so without further ado, I'm going to get into the talk. By the way, before I go on, who heard of responsibility-driven design or read books about it before? Okay, well, I'll talk more about it then, and I'm glad you came here. So, I mean, first I'm going to give you an outline of the talk. I'm going to start with just an introduction to object-oriented programming, and then I'm going to jump into what responsibility-driven design is, and then I'm going to talk about a variation of it called responsibility-based modeling, and then GRASP, and then consolidated OO design process, which basically summarizes all of them together. So, I mean, to just start with an introduction of OOP, I'm sure all of you have worked with OOP before. I'd be surprised if you haven't. It's basically a way to build software that has the following key features: data abstraction. So you want to abstract real concepts like a car, like an order, like a tax calculator, like something like that, into objects, so data abstraction. And then there's encapsulation. Encapsulation is basically hiding data. So if I have a car and it's got a wheel and it lets me turn left and right, I don't care about the speed variables within the engine and how they're doing the work. All I care about is the steering wheel. So that's like a way of encapsulating the details of the car. Messaging is just the way objects can talk to each other. Obviously in Ruby we're all familiar with messaging because that's how Ruby works as far as like invoking methods on objects. It's basically inspired by Smalltalk's and Smalltalk's approach to object-oriented programming, and yeah, it's called messaging. Modularity is just dividing a system into many smaller objects, so it's a way of dividing and conquering complexity. Inheritance. We're all familiar with that. That's a way of representing inheritance in real life. So like if I have a vehicle, it could be a car, it could be a truck, it could be many different things. There are many kinds of vehicles. So that's what inheritance is. Polymorphism is just a way of having an operation get varied depending on which object is invoking it. So for example, if I'm moving a truck, it'll move at a different speed or different acceleration characteristics than moving a car or moving a different kind of vehicle. So every vehicle will have a move method, but it'll have polymorphic behavior, meaning it'll vary from object to object with different types for the inheritance hierarchy. So the talk today is basically going to revisit the basics of object-oriented programming and how to do it the right way. There are many ways, many books on doing object-oriented programming, but I feel like there's a bit of lack of knowledge on how to do it the right way. And this is just a reminder of how to do it the right way. I mean, I've learned this approach during my master's degree in software engineering, and I've been applying it at my job for like 15 years since then, and it's been very, very solid, like very helpful. So responsibility-driven design is an object-oriented design technique that came from Wirfs-Brock, who is famous for writing a book called Object Design. That's one of the famous books on object-oriented programming from the 90s. But it's a very basic, it's a simple book actually. But basically, she came up with this approach as a reaction to data-driven design's lack of encapsulation of object data. So a lot of people, when they start programming, including me, I started learning let me ask maybe a show of hands. What language? How about this? Tell me what language you started programming with. What was your first programming language? PHP. What else?
Quick Basic.
Quick Basic. Okay, that's what I started with. I started with Basic.
Yeah,
Python. What? What did you say? Sorry.
Visual Basic.
Visual Basic. Okay. Awesome. Yeah, so I mean, when I started with Basic, it just, I started with a very old version of Basic from the 80s, and basically you just say a number, like 10, and then you specify a variable, and then 20, and then you specify something, and then you could do loops where you could go back to 10 from 80, and that's how you do a loop. That was one way of doing it, using a goto statement, which today is considered very bad. So anyways, that way of programming was absolutely not object-oriented at all. It was very procedural, so that was procedural programming. That's like one of the most basic techniques of programming. So a lot of programmers start that way, and then they graduate from that to like maybe using C and building structs, like designing data in structs. And structs usually, in general, if you're not doing object-oriented pattern in C, structs are very dumb. Like they're just data holders, and you can pass them around, and then you have operations separate from them. And that's kind of like what the data-driven design approach was. It was very data-oriented. It was about focusing on what is like. It was a bad way of doing object-oriented programming. Basically, it was you think what is the data, you put it on an object, but then you don't put the operations on that same object. You put them somewhere else. And if you split data from operations, you're defeating the whole point of object-oriented programming, basically. Because the whole point is abstraction and like having a vehicle hide the details of its engine behind the steering wheel so that I don't have to worry about what the engine is doing. If I have to worry about it, it defeated the point completely. So that's what responsibility-driven design came from. It basically was an approach that would basically focus on object responsibilities and collaborations between objects. So object interaction follows more of a client-server model, but a virtual client-server model. So like you have an object and another object, and it's kind of like one object is the API and one object is the consumer. So we're all familiar with this pattern. And the consumer will call the API of the other object. So that's kind of like client-server, but in a virtual way, not exactly a real client-server, although it is applicable to real client-server too. So the process behind responsibility-driven design was very simple. First, if you're thinking about a problem and you have a user goal in mind, think about the actions that the user must take to accomplish that goal. So for example, if I'm, let's just say I wanna add a bunch of products to a shopping cart. So the goal is to find the items that I need and add them to a shopping cart. So first I have to browse for all the available items, and then I have to, there are multiple ways of doing it. I can either go through categories or go through a search engine that would let me search for products by name. And then once I find them, I can add them one by one, and then I can specify the quantity. So I just mentioned a whole bunch of actions that I had to take to complete this goal. So those actions are what we start with in this process. And then for each action, we need to identify the responsibilities that are needed to fulfill the action. So the key thing about responsibility-driven design is you're focusing on responsibilities, meaning in a way the work. You're not focusing on the data. The data is secondary, because you're going to hide the data. The whole point is we're going to do encapsulation. So we don't want to worry too much about the data. We want to worry more about the work and where to put the work on what objects. So next, after we identify the responsibilities, we need to identify the objects that are most suitable for those responsibilities. So I mean, an example of responsibilities is if I'm listing products, then one of the responsibilities is retrieval of products from the database. So that's like a repository object. So I can use, so the responsibility is data retrieval, and then I can assign it to a repository object. And then that object would become like product repository that would be responsible for retrieving products from the database, for example. Finally, objects, you cannot use one object to do the whole task. Objects need to collaborate together in order to fulfill responsibilities. So you're going to have to think about the collaborations between the different objects and orchestrate them together in order to complete a task or complete a job. And finally, once you came up, so you start with a goal, and then you break it into actions, and then responsibilities, and then objects, and then collaborations, and then you've solved part of the problem, part of the puzzle. So then you iterate, you go back to the beginning and start with a different goal. And again, you break it down, break it down, break it down, till you come up with new additional objects. So you keep iterating over and over till you've solved the entire software system with this approach. So let's look at an example of this. I'm just going to show a very simple Ruby example. So the action is add a new address for a user. validating the address and filling in the postal code automatically. So for example, let's just say there's a user. I know the user ID. I don't care who the user is. And I just want to add an address. So I'm going to add the street, city, and province. And that's it. And then the system is smart enough to figure out the postal code automatically for me. So responsibilities. Create a new address. Validate the address. So validating the address is making sure the user entered a street that exists, not like a street that doesn't exist. Finding the postal code for the address. So that's a different responsibility. And then finally, the last one is adding the address to the user addresses. So that's what completes the goal. So we can start with an address factory. That will help us create the address. And then an address model. That'll help us validate the address. And then a postal code service, which will help us find the postal code for an address. So if I give it street, city, and province, it'll give me the postal code. And finally, a user model that will enable me to add the address to the user addresses. So let's start with a code. So I built a really dumb command line application. So it's right now namespace under responsibility-driven design. So that's just the common namespace. But yeah, it's just application. When I initialize it, it creates an address factory and a user. So here I'm importing an address factory and a user. I'm requiring them. And then here, it's just going to do command line collection of data using, so it's going to print a statement, and then I'm going to enter this street, and then it's going to ask me for the city. So to limit it and make it simple, I'm just basically saying that the street always has to start with a number and end with a letter. So that's the validation for the street. For the city, it's just going to be Montreal or Ottawa. These are the only supported cities. Provinces are only going to be Quebec and Ontario. That's it. And so here, after I've collected all of them, then I can use the address factory to create the address. So I can pass it these 3 pieces of data, and it's going to give me an address model. And then next is, okay, so here it's saying found address postal code as. So what that means is that the factory is actually also, as part of its work, it not only does it create the address, but it also populates the postal code for the address by using the postal code service, which we'll get into in a moment. And once I have the address, the final task is to add it to the addresses of user, and that's it. So, I mean, this is just a simple way of doing object-oriented programming using the RDD approach. So let's dig deeper now. I mean, at the last line, I'm just printing everything. I'm making sure that the data got stored in the addresses correctly on the user. And I'm just printing everything, that's it. But yeah, now let's go to the next. So the next model is just the address factory. So this is gonna be, it's gonna basically receive those 3 pieces of data. It's gonna create an address model. The address model knows how to validate itself, so it's gonna invoke validate on it. And then it also knows how to find its own postal code. So it's gonna invoke this on it, and then it'll return it. Next is the address model. So this is just, it holds the basic address information. It initializes its own data. It has a postal code service that will figure out the postal code at the end. It has a validate method. The validate method will basically, it's just very simplistic validation right now. It's just going to raise errors if the street doesn't match this pattern, which is, starting with a number and ending with a letter. The cities have to be Montreal or Ottawa, so it's very dumb validation, nothing special. See, we have here the cities, Montreal and Ottawa, and we have the provinces, Quebec and Ontario. Then the last one is just making sure that for Montreal, you can only enter Quebec, and for Ottawa, you can only enter Ontario. And that's pretty much it. The last piece of the puzzle is this, find postal code. So find postal code is gonna delegate the work to the postal code service. So this is an example of collaborations between objects. So this object is gonna collaborate with the postal code service, which will then find the postal code for self, meaning an address object, and it'll return the postal code, which will get assigned immediately to an instance variable here. But the key thing is that the work is not happening inside this class, it's happening inside another class, so it's a form of collaboration. Next is the postal code service. It's a very dumb, simplistic implementation right now. It's just, taking, it's just looking at the city, and if it's Montreal, it's assuming one postal code only for now. If it's Ottawa, it's assuming another postal code. That's it. And last is the user. It's just a user that has an email and addresses, and then here I just add the address to the list of addresses, and that's it. So now if I, let me run the app. I have it actually on my machine locally. Is this large enough?
Yeah.
Okay. So first it says, what's the street address? So I'm going to put 123 Main Street. City, I'll put Montreal. So if I put Ontario here, it's going to freak out. See, it said invalid province name. So it is doing validation. So let's try it again. Yeah, I mean, again here, if I end with a number, it's also going to freak out. Doesn't matter. So yeah, invalid street address. So anyways, that's just proving that there are validations happening. Okay, so now this time it actually finished the task, and it generated a postal code, and then it generated the full address, and it stored it in the user addresses. That's it. So very simplistic example, but it's just showing the full process of responsibility-driven design in action. So let's get back to the slides. Okay, so responsibility-based modeling was actually a variation that was invented by a very famous software luminary, Alistair Cockburn. Who here has heard of Alistair Cockburn? Not famous enough, apparently. Yeah, so he's famous for something else, which I'm going to talk about. Have you guys heard of elephant carpaccio? It's a way of it's a way of doing iterative development with very small slices. But that's another thing he's famous for. But anyways, so responsibility-based modeling is basically, he took responsibility-driven design and expanded on it. And he's like, let's take this and provide a larger process that would enable me to solve the entire system. So responsibility-driven design is a very small focused process that always begins with an action, but I have to provide the actions and do the other work on the side. Whereas here, this basically, let's go into it. It begins with very high-level component design, and it delves down into object design. The key thing about it is that it uses use case scenario steps as the actions for which responsibilities must be identified. Objects can be identified using CRC cards or object interaction diagramming. So CRC cards stand for class responsibilities collaborations or collaborators. So that's a technique for coming up with objects that helps you basically on real paper. You take a piece of paper, you put every time you come up with a new object, like let's just say address, I put address on the top as the name of the object. On the left side, I put the operations, like the responsibilities. What does an address do? For example, validate an address. And then on the right side, I put the collaborators. So it collaborated with the postal code service, so that's one of the collaborators. So CRC cards is a way of doing that on paper. I've actually worked for a company that used that in collaboratively between multiple developers. So multiple developers would go into a meeting room. They would bring a deck of cards that are CRC cards that are empty, and they fill them up gradually as they come up with objects, and then they put them all either on a table or on a board next to each other, and they kind of connect them together. So yeah, it's an interactive paper exercise for discovering objects and collaborators. Can be done collaboratively by multiple developers. So yeah, that's what I was talking about. It's that's the name of the object at the top, or class. Here are the responsibilities or operations, and that there is the other objects that this needs to collaborate with in order to get the job done. So yeah, and usually, yes, when you come up with multiple objects, that's how you come up with them, like multiple cards, and then you connect them together in a way. So that's one approach. The other approach that's also valid is object interaction diagramming, which also helps us come up with objects. So this one, maybe more people are familiar with this approach. Basically, yeah, it documents collaborations between multiple objects. It helps developers discover objects and responsibilities. The most common diagrams for this are UML sequence diagram, which many people have heard of, and communication diagram, which is an alternative approach for doing sequence diagrams. I mean, communication diagrams are more compact, and they're not like, they don't go linearly down like sequence diagrams. They're more like you define all the objects, you put them all next to each other, and then you connect them with lines. I'm going to show you examples in a moment. So here's a sequence diagram. A lot of people are familiar with it. So basically, the flow of time starts from the top and ends at the bottom. You start with an operation here, like verify a ticket, and then it gives me a verification ticket, okay. And then I say, okay, load luggage. And then it loads luggage into the baggage transportation object. So this collaborated with another object. Sometimes multiple objects have to be involved in an operation. Also, it informed it that it needed express seat preference, so this will take that into account. And then it'll give me a boarding pass, and then finally I verified the boarding pass with the passenger service boarding object, and it tells me boarding pass is okay. So that's what sequence diagrams are. So they're a way that helps you discover responsibilities and collaborations. So it's a helpful diagram for that purpose. A communication diagram does the same thing, except it does it in a layout where you put all the objects that you need next to each other, and then you just connect them with lines. And you start with like 1.0. Okay, 1 is actually the top goal that you want to accomplish, calculate total. And then here you say 1.1, you break it down. So every time you add a point, you're breaking it down into subtasks. So get quantity, get product from an order line of an order. And then 1.3 is you have to get the price of the product itself. So now you have to collaborate with another object. And then 1.4 is calculate the base price and then calculate discounts. And part of calculating discount is for a specific customer, there might be different discounts. Like different customers have different discount codes, for example. So you get that from the customer. So that's another form of collaboration. And finally, you finish calculating the total. So that's a different way of doing things. Sometimes at work, I actually prefer to use this kind of diagram because it's a lot more compact. So it's easier to draw on a whiteboard and to like share it with people. It's good to know about both diagrams. Both of them are very useful. So let's go into a responsibility-based modeling example. So often when you want to think about the system at the highest level, you can think of this start with a diagram called business context diagram, which basically puts the software system that you're building in the middle, and it puts all the actors around it. So right now I only have two actors. I have a customer and I have a warehouse clerk. It's an e-commerce system, and here the arrows are not operations in this case. The arrows are just the data that is passing between the different objects. So basically I get a list of available products, and then the customer makes a product order. And then finally, the e-commerce system is gonna inform the warehouse clerk of the sold products so that the warehouse clerk would ship the product. And then the warehouse clerk can actually update the inventory by informing the system of the added products. So that's just a very simplistic example. It's not very realistic, but it's just an example. So if we start with something like that, so we have multiple actions that happened, like multiple responsibilities, like putting an order in, listing orders, providing the information of the orders in order to have them get fulfilled, and then being informed of new products that got added to the system. So the actors in this case right now are just customer and warehouse clerk. And the key thing in the responsibility-based modeling process is that we use use cases as the unit of requirement that we begin with before we dig down and discover the objects. So instead of starting at actions, we start at a level higher than actions, which is use cases. So in this case, the customer has use cases: browse available products and add products to shopping cart, and check out shopping cart. And then the warehouse clerk has his own use cases, which is add products to system and read product orders for fulfillment. So now we're just going to zone in on one of those. We're not going to handle all of them at once. So we're going to use one of the customer use cases, which is the checkout shopping cart. And the level below use case is use case scenario. Scenario is basically you take the use case name and you break it down into multiple subtasks, like multiple steps, basically. So system presents shipping address form. User adds new shipping address. System presents payment method form. User enters payment method, which includes adding new billing address for user. System presents order confirmation. User places order. So basically, this is a use case scenario, and there are multiple actions from the user side. There's this action, and that action. So now we can zone in on an action and figure out the responsibilities. So for example, for adding a new shipping address, it's the same stuff we went through earlier, creating a new address, validating, finding postal code, adding to the user. The last one is setting the shipping address for the order. Next, user enters a payment method, so then they have to create a new payment method, create a new address. I mean, this is not very realistic, but it's close enough, like good enough for teaching the concepts. Validating the payment method, adding the payment method to the user, and setting the payment method for the order. Finally, the user places an order. So that's the third action that the user did. So that one is just place order and authorize payment. The responsibilities that are needed for it, so the user will just place order, but the system has to know how to authorize the payment when placing the order. So that's why that's another responsibility that's concerned there. So if we were to use CRC cards next, so next we have two options, or three options really. CRC cards, sequence diagram, or communication diagram. So if we were to use CRC cards to break the system down, we can start with like the top level model that we thought about, which is order. And the order has to be able to set its own shipping address, payment method, place an order, and authorize payment. And it needs to do the work, it needs to collaborate with user and payment processor. Payment processor is needed for authorized payments. User is needed for figuring out the shipping address and payment method. Next, if we dig a level deeper, there's user. User can add an address and it can add a payment method. And it has to collaborate with address factory and payment method factory to do the work. Payment method factory, now we dig a level deeper. It can create a payment method and it can validate it. And it collaborates with the payment method object. So I'm not going to do the whole thing. Like, you could practice on your own after the presentation, or like at your own time. But that was just a quick example that walked you through all the steps, all the way down till we discover the objects, basically, because those CRC cards are the objects in the end. So we figured out a number of objects here already. This is the sequence diagram approach. So we have an order. Whoops. Okay, so the customer needs to place an order. So it's going to retrieve the payment method from the user. And then once it has it, it's going to use the payment processor to authorize the payment. And once it has the result, it's going to give the user an order receipt. So this is using a sequence diagram to figure out objects. We have an order, a user, and a payment processor. The collaborations are between these three objects, and the responsibilities are those lines, the ones that are going to the right side. Okay, so I've covered two approaches for doing object-oriented programming. Now we're going to go into the third technique, which is grasp. So grasp are actually patterns. So kind of like how there are design patterns and there are architectural patterns. So architectural patterns are high-level patterns that are like for the general architecture of a software system. Design patterns are like a smaller scale patterns that are about the collaborations between a few objects in a system. Like, for example, bridge pattern, or design, or visitor pattern, or strategy pattern, etc. Now, grasp patterns are a level even below. Grasp is the lowest level of patterns. It's basically patterns that are so low level that they're focused on one object usually, or sometimes two objects at a time. and they're more about how to figure out how to assign responsibilities to the right object. So for example, like if I want to validate an address, a bad anti-pattern that I've seen a lot in Java programs is that you would build, well, I mean, there are different ways of doing it, but you can have an address validator class separate from that address, and it does the validation. The issue with that is that it breaks the system to too many objects sometimes. Like to split it into an address validator is actually not necessarily the ideal approach sometimes. Sometimes it's simpler, like in Rails often the model will do the validation. So if I have an address, it'll have its own validations. So in this case, they're actually applying one of the grasp patterns. So the next, let me go to the next screen just for a second, just to make my point. So this second pattern, information expert, is basically saying the object that holds the data performs the modification on the data. It's not just modification, it's also the operation of the data. So if I want to do a validation, the object that holds the data for the validation is often most suited for doing the validation because it has the data for it. So in that case, address can do the validation. So that's why it's a good object for it. Sometimes there are reasons to build an address validator. If I wanted to specialize the validation and have multiple versions of it in a strategy pattern, then I can make an address validator and a hierarchy, inheritance hierarchy, where there's a different, like for example, US address validator, Canadian address validator, Australian address validator, etc. In that case, I'm using the strategy pattern, so I had to do something else. So actually, grasp are just patterns that they're not hard and set rules, but they give you guidelines, and they help you. And when you apply grasp, usually you have to balance 2 different or 3 different patterns at the same time and figure out which one is best for your system. Different systems will have different requirements. So just to go through what it is, basically they're general responsibility assignment software patterns. They help us figure out how to assign responsibilities to objects. They help, yeah, so that's exactly what I just said here. Contemplated collectively, so that means sometimes you contemplate multiple of them at the same time. So you might want to balance the information expert pattern versus there's another pattern called controller, and there's a third pattern called high cohesion. So I'll go through them in a moment, but sometimes you have to think about them at the same time. So yeah, they help with the underpinnings of object-oriented design, meaning like figuring out how to assign responsibilities. So in a way, those grasp patterns help with everything I talked about before, which is responsibility-driven design and responsibility-based modeling. So they kind of help at the level of doing the CRC cards, for example, or doing sequence diagrams. When you're doing the lowest level of object-oriented design using responsibility-based modeling, and you're trying to think of where to put the responsibilities on which objects, that's where you can use the help of grasp patterns to help you figure out where to put them. Oh yeah, they explain how design patterns are arrived to. So I mentioned that these are lower level than design patterns. So there's architectural patterns, that's the highest level, and then design patterns, and then grasp patterns. Often, some of the patterns that you see in architectural patterns and design patterns originated from grasp patterns. They're related in a way, and you'll see it in a moment. So for example, the first one is creator. So this one is saying often when you're creating an object, and there's a lot of complexity with creating the object, you want to apply the pattern of creator, meaning come up with an object that's specialized and focused only about creation of objects. So that in design patterns, that's basically the abstract factory pattern and the factory method pattern. So those patterns came from creator in a way. Creator is like the more general version of them. So it's a way of coming up with factories, basically. So like in Rails applications, often we use the active record to create a model. But that's for simple cases of creation. But if I have to create a model that's very specialized, for example, in my work application, we have to do imports of CSV files. And when we're creating models from CSV files, the data comes in a special format that needs special massaging and like normalizing before we create the objects. So for that case, if we put the logic in the active record, it's too large. It takes too many lines of code, and it's too complex, and it makes like the active record model is bloated. So instead, we actually do use the factory pattern, like the creator pattern, we separate that logic into a factory that's specialized only for import creation. And so so we have an import factory that's focused on creation related to importing. So the second pattern is information expert. So I already went through that one. Usually, this is the simplest one to start with. This one is basically the object that has the data should do the operation. So if I have an order and it has order lines, and I want the order total, the order has the order lines within it. So it's the most suitable object for putting the order total top level algorithm or method. And then the order total method can actually delegate part of the work to the order line as well. And the order line would focus on one product at a time. So that's a way of dividing and conquering the work using information expert. Controller is basically orchestration of multiple objects in order to accomplish an action or a goal. So you can see this name is so similar to controller from MVC. So that's like the lowest version, like low-level version of controller that spawned MVC controller. So here, what they're saying is actually you can use controller for anything, not just for MVC. We're used to just using controllers in MVC where you have a view which presents data to the user on the screen, and then we have a model that does the business logic on the data, and then we have a controller that's like the glue that connects the view into the model and it enables people to submit control actions, like for example, clicking a link or submitting a form. That usually will trigger a controller. So here what this is saying is not only that, but even if you just need general orchestration of multiple things at the same time, like if you need an object that needs to be aware of multiple other objects to get a job done, then this object now follows the controller pattern. And it doesn't have to be an MVC controller. So this is kind of like in Rails nowadays, you see this in service objects. People often will build service objects that will orchestrate work between Rails controllers and models, so they sit in between sometimes. And those service objects are in fact actually following this controller pattern here. I personally don't like the name service that much. When I build those objects, I try to name them something else that's more related to what they do. But either way, service objects in Rails is controller pattern. Low coupling is basically saying that if I had an object, for example, the postal code service. So the postal code service needs an address in order to figure out the postal code. The way I built it was you just pass it the address and it gives you the postal code. Unfortunately, this approach has the trade-off. The trade-off is that it couples it to the address model. If you want to decouple it from the address model and accomplish low coupling, you can actually have it take the city, province, and street directly and avoid the middleman, which is the address. Now, it's a trade-off, because if you do that, then the code becomes more complicated sometimes, because now you have to write more code every time. I have to pass things in a fine-grained way. Whereas if I already package them in an address object, it's simpler to just pass an address. But if there are issues where the address, let's just say, there's a US address and a Canadian address, now that's coupling it to details of the country. And if you don't want that, you can basically decouple it from address by either passing the low-level data directly or by using other patterns, which I'm going to get into in a second. But that's what low coupling is. So again, nothing is set in stone. For every problem you have, you need to think about those different patterns at the same time to figure out the best solution. The next one is high cohesion. So low coupling and high cohesion are famous as like general principles for object-oriented programming. Usually you want objects to be highly cohesive, meaning they're focused on object responsibilities. Meaning if I have for example, let's just say I have a vehicle, and the vehicle, so a vehicle in real life, I can actually not just drive a car, I can also turn a radio on and change stations and change the volume. Now imagine putting all of those responsibilities on one object called vehicle. That can get nasty, because if you're putting all of those different responsibilities on that same one object, that's making it not cohesive anymore. If you want to make it more cohesive, then you can divide those responsibilities into multiple objects beneath vehicle. So then a vehicle delegates work to a radio object and an engine object, and those objects will then focus on the other responsibilities. So that's a way of increasing the cohesion of the vehicle, making it more high level, just focused on what the user cares about, but not the low level details. Polymorphism, I already talked about it. It's just if you have an inheritance hierarchy, then a method will vary between different objects. So a truck move method is different from a car move method because they have different engines, for example. Pure fabrication is a cop-out. So basically this is saying if you thought about all the other patterns and you couldn't come up with a good satisfying object to put the responsibility on, you can just invent your own pure fabrications. So this is basically, so this is an example of if you have a class, for example, postal card service is a bit of a pure fabrication. So postal card, postal code, service. We don't have a real service in the sense that there's a service clerk sitting on a desk and responding to us and giving us the results. It's not, but we called it a service. It doesn't represent a real life concept. Usually pure fabrication is a software concept that does not represent a real life concept. We just came up with the name service because we thought it was suitable to abstract the idea of like coming up with postal codes for addresses. But the name doesn't necessarily map to a real life object. So this is what pure fabrication is. The opposite of this is information expert, or like just basically if I have a car, I just make an object called car. That way I'm not doing pure fabrication. But sometimes if you have work that doesn't fit on car and it doesn't fit on a car repository either, and you need a third object, like an orchestrator, you would apply this pattern sometimes and come up with, like for example, service. Services are often a pure fabrication. Indirection is basically a way to decouple two objects. So I talked about this earlier, is if we want to decouple the user, or not the user, the postal code service from the address, because the address could be a US address or Canadian address, then you can introduce an indirection. So that way you would have a general address interface or abstract address that the service will work with without caring about which concrete address you're using, and then you have different addresses that fit different countries. That kind of fits in with this as well, protected variations. So protected variations also fits in with that, is the idea of protecting the postal code service from the variations of different addresses for different countries. So this one is focusing more on the fact that we have an inheritance hierarchy, whereas this one is more focused on the fact that we lowered the coupling and created an indirection. Sometimes this means we need like a mediator between two objects to connect them together, like the bridge design pattern, for example. So anyways, that's pretty much it. So let's go through an exercise. So I used to work at Groupon.com in Chicago. They've actually acquired a previous company that I worked for 6 years. And anyways, so we used to have to provide a way to navigate through deals on the website. So it's kind of like an e-commerce website, but except it's for deals. The product is deals. And so for example, one use case is search for deals near my location. That was the most common use case, if I remember right. And one way of writing use cases, by the way, is to use the cucumber approach as well. That's an alternative way of writing them, is to do given, when, then. So let's just say I say, given I live in Chicago at 60622 zip code. When I sign into the system and I request a search for deals near my location, and I specify keywords for finding deals, then I am presented with a collection of deals that match the specified keywords, and at the same time, it's ordered by distance in ascending order, depending on where I live in Chicago. So it does have my address, and it orders the deals in distance based on my address. So lots of responsibilities are involved with this. There's user lookup. When I first sign in, it has to look up the user. There's user authentication, has to verify my password. There's user information storage, like just representing a user. You need a user object that holds an address. User interaction, request handling. So this is, I think, was about figuring out what are the actions that the user has in the system and interacting with them. Presentation of a search input form. So this is, we need to present a search input form for the user to type in keywords in. Search form input handling. So once they're typed and they're submitted, you need something to handle the submission of the search form input. Searching for deals. So obviously, eventually you're going to search for deals in your system, figure out which deals are closest or match the keywords. Ordering of the search results based on which ones are closest. And then for every deal, retrieval of deal information as in metadata or everything related to a deal, like the name of the deal, the description of the deal, the price of the deal, etc. Presentation of deal information. So eventually you're going to need something that will present it on the screen to the user. So this is just a quick example I'm going through. I'm not doing a very I'm not going through every permutation of how we can think about graph patterns here. It's just one example. So for user lookup, a very common pattern is user repository. So it's high cohesion in the sense that it's focused on retrieval from the data, like retrieval from a data repository, like a database. So it's a highly cohesive object that's focused only on data retrieval. And then user authentication could be done using an authentication service. So when I worked at Groupon, they had microservices, and like we had to talk to a separate microservice to do authentication. So that's just an example of that, like where you have to interface with another system. And so it's a bit of a pure fabrication, and also high cohesion, meaning it's focused on authentication. This one is just user information is going to be held in a user object. It's not exactly an information expert, but it kind of is. So there are better examples of information expert. I think the one I provided earlier was better. Like an order can do its own calculation because it has its order lines. That's a very good example of information expert. But okay, so next is user interaction request handling. So so figuring out, let's see, deal search controller. So this is just figuring out that the user provides me with the operation of searching for a deal. So one way of doing it here is applying the controller pattern, and the controller is going to encapsulate all details related to searching for a deal. And it's going to orchestrate multiple objects to get the work done. That's why it's a controller. Presentation of search form, search input form. This one is just information expert. So basically it's an object that's focused on showing me a search input field, which is a form on the web. So it's an information expert about the entry of data into a form. That's it. Search form input handling, which is basically when I submit the form, it's going to talk to a deal search controller. It's the same object as this one, the same controller, and it's going to submit search. And then searching for deals, deal search service. So the controller is going to collaborate with another object called deal search service, which will, so that's another micro service. So we had a microservice that was only focused on deals or deal retrieval. So here I have to talk to a deal service, basically search service to do the work. It's pure fabrication because it's a service. It doesn't represent a real object. Not exactly. Like a deal is a real object, but a deal search service is not exactly a real object. And it's highly cohesive. It's focused on search and deals. Ordering of search results, also it'll be done by the deal search service. One key thing about RDD in general is that it's a very balanced approach to object-oriented programming. It's not dogmatic in the sense that you have to have only one responsibility on one object. It's okay to have multiple responsibilities on an object because, like I mentioned earlier, like a car might have a radio and an engine, and you could divide that into two different objects that will focus on that with high cohesion underneath the car. But the car itself will still have to have those two responsibilities because when you're inside a car, you can turn on the radio or you can drive the car. So it's okay to have multiple responsibilities, but as long as you're thinking about the graph patterns and sometimes offloading some responsibilities to other objects when you have too much code in a certain class. Retrieval of deal information. So this is retrieval of the deal information from the database is what this means. So deal repository. Presentation of deal information. This is a deal view, which is a bit of a pure fabrication, a high cohesion and indirection. So it's focused on view concerns. It's indirection because it doesn't have, a deal view will grab a deal object and then let you view it. But it's indirectly pulling the data from a deal object. It doesn't hold all the data itself. It separates the view from the model, basically. So that's why it's indirection. And it's pure fabrication in a way, because a view is not representing a real object. It's just a software concept. And that's pretty much it. This is just a quick note here that sometimes the responsibilities, like an object might have a responsibility, like a user might let you sign in and basically validate the password of the user, but that doesn't mean you have to do the work inside the sign-in method. The sign-in method itself could delegate the work to a sign-in service. So that way you can still, like I mentioned earlier, a car can have a radio and an engine, and the car doesn't have to hold the code for both of them. It can still delegate the work to them, but the car has those responsibilities still from the user point of view, because I do, when I get into a car, I do want to turn on the radio or drive the car. So let's consolidate everything together now. So we start with functional requirements, meaning like how people think of requirements at the highest level in English, and you break them down into use cases. Then you take a use case and break it down into a use case scenario, meaning steps. And then for every scenario, you identify the actions. And for every action, you identify the responsibilities. And then for every responsibility, you want to pick the object that's most suitable to fulfill it, using grasp patterns as guidance. And usually you do this with CRC diagrams or a sequence diagram or a communication diagram. And then you review the responsibility assignments done for the picked use case scenario, possibly altering your decisions based on grasp. So even after the fact, sometimes you might move responsibilities around between different objects. And you keep, it's an iterative process, so you keep repeating until done with all use cases. So this is done for one use case at a time and one iteration's length of requirements at a time in an agile process. So in an agile process, you want to implement one of those use cases at a time. So like maybe each one would take 1 week, for example, or 2 days or something like that. You want to break them down. And this is where we come back to Alistair Cockburn's elephant carpaccio, which is a way of basically breaking software development into very small, thin slices, where one slice will add just a user signing into the system. Another slice will add a user adding a shipping address. That's it. Another slice will add, adding a payment method, and then after that, it'll be submitting an order, for example. So it's by developing a system in very thin slices, you can be very incremental and iterative, and that way your processes will be lean. You will not have to handle, you don't have to implement a feature in 3 months. You can divide a feature into very small slices and do one mini feature in 2 days, another mini feature in 3 days, another one in 1 week, etc., etc. Usually you don't want to exceed 1 week. 1 week or 2 weeks, depending on whether you're doing a two week iterations or not. If you're doing Kanban, then you don't have any fixed iteration lengths. So in that case, yes, some features might take 1 day, others might take 2 days, others might take even a few hours, and then others might take a week, for example. So as a review, we basically went through an introduction of object-oriented programming. Then we covered responsibility-driven design, which is a technique by Wirfs-Brock. And then there's responsibility-based modeling by Alistair Cockburn. Grasp, by the way, is by a Montrealer, by a guy from Montreal called Craig Larman. I don't know if you guys heard of Craig Larman. He lives in California right now, I believe, but he wrote a book on grasp patterns. The book has a different name, which I'll have in the resources at the end of the slides. And then finally, a consolidated OO design process that kind of unify all of those together. So when you practice this a lot, eventually you don't follow this process this dogmatically anymore. You become very fluent in it, and sometimes you might be able to think of the CRC cards in your head. You don't even need the cards anymore. And there are other times when a problem is really complicated and it's helpful to have a CRC cards. And there are other times when a sequence diagram is better, other times when a communication diagram is better, but eventually it becomes a very fluid process that depends on the problems. And when you get really good at it, you'll start noticing patterns and common solutions to a lot of, for example, if you need any sort of data retrieval, often a repository is the best object. So once you get really used to it, eventually you won't have to go through every step as dogmatically as presented. You'll become very well versed in it. You can think about solutions instantly almost. So practice makes perfect. So yeah, that's pretty much it. And these are the references. There's the responsibility-driven design comes from this paper. Responsibility-based modeling comes from that paper. And grasp patterns come from this book. It's a great book, by the way. Applying UML Patterns, Introduction to Object-Oriented Programming. It's a very, very interesting book to read, actually. It has a very generic name that makes it sound like it's boring, but it's actually not boring at all. It's a very interesting book. Actually, I did learn about it from my master's degree. That's how I discovered it, but I still highly recommend it. So yeah, that's pretty much it. Thank you guys for attending. So, do you have any questions?
Yeah.
Go ahead.
When you have multiple responsibilities that use the same data, how do you avoid sending too many messages? Like suppose sometimes I've seen like the order that needs to get the price and then also get the availability. That's probably like stored in the same place, so you could either like send two messages back and forth, or maybe like load the whole order up front and then like use just part of the data. Like, is there some ways to avoid like too much chatter over the network, say, for stuff that takes a long time to?
Right. The scope of this information does not concern itself with parallel programming or concurrency, because it sounds like what you're talking about is concurrency. Where like sometimes you're able to retrieve two pieces of data, for example, from two microservices at the same time, and once you have them both, then you can do something with them.
Well, suppose it's the same. Like, suppose I'm just building a database query and I'm doing it like 5 responsibilities at a time, but all the data is in the same place, and I would like to bundle it. Like, how can I do that?
Right. So in this case, like those patterns are at a much lower level. They don't concern themselves with concurrency, but they're more about designing the objects within a system that's assuming you are going through a sequence of steps. However, if you feel like you're always retrieving, for example, let's just say you're always retrieving postal codes for addresses, and you're retrieving distances for them at the same time from where the user is, then that's more the responsibility of whoever is building that API for you, and they can actually bundle things together if they want, if they discover that saves you response time and improves performance. Because you're right, there are times where services there's too much chatter between services. You're having to talk like 20 times to get a job done that could have been done with 3 different calls only. I know about that problem. That's part of the reason why I personally discourage using microservices till the very last moment they're needed. Because if you build everything with microservices from the start, you end up with a lot of chatter, which causes very bad performance problems. So in my job, I work very hard at like not doing microservices unless we really need it in my current company. But yeah, in that case, it's more the responsibility of that API, and it has nothing like, it does have something to do with this. So in that case, it's pure fabrication. You want to apply the pure fabrication pattern, because what you're doing is you need a bundle. A bundle is a new object that's like custom, that you thought about because you discovered that there's data that you're always pulling 2 pieces of data at the same time that are not necessarily the same thing, but they're always needed at the same time. So that's pure fabrication. So you can come up with an object and call it, let's just say, an address bundle or user address bundle, and that would give you everything related to both an address and its distance from the user at the same time. So that's pure fabrication. Any other questions? Okay, thank you everybody for coming.